diagram, cause and effect, check sheet, okay, flow diagram, scatter diagram, histogram, and so on. So I ask you to plot a histogram, okay, histogram. Okay, we ask you to put a histogram and also scatter diagram. Okay, I will come back to that, because last time, okay, you give your weight and also height. Okay, weight and height. So with the hope that you can get interpretation of that. So this is basically for if you have learned statistics. Basically, you just implement it in this. Okay? So this is histogram, and this is scatter plot. Okay. So in quality, as I mentioned earlier, okay, normal distribution is commonly used. Okay, normal distribution where you have this. When we join this as a line, you get normal distribution. A perfect distribution will be in terms of bell shape. Okay, bell shape. But there are many other shape for distributions. Okay, it could be geometrical distribution. It could be triangular. It could be uniform. Okay, sometimes we have a shape just a simple like this. Okay, just a simple distribution, just a uniform. Okay, uniform distribution. For example, okay, if you are tossing a dice, okay, you know dice, right? You have a dice. How many face you have on dice? Dadu. Okay. Berapa muka ada? How many face you have?
6.
6. Okay. 6. So you have face number 1, you have number 2, okay, maybe number 3, and then you have 4, 5, 6. Okay. So what is the chances of having the face? Okay, let's say this is the okay, the probability, the probability of having face number 1. Okay, you have 1, you have 2, you have 3. What is probability of having the face? 1, face 2, face 3.
1/6.
1/6. Okay, 1/6. So, assuming the shape of the dice is evenly, perfectly the same. Okay, there is no extra length or no extra height of it. So you're going to have 1/6 chances of having face number 1, face number 2, face number 3, and so on. Okay, if you have a coin. You toss a coin. What is the chances to have a head or tail of the coin?
1/2.
1/2. So what is the distribution of this coin? How is the distribution will look like? For a coin, you're going to have you're going to have a head, or you're going to have a tail, right? Ataupun you can put it as 1 and 2 lah. Okay. So the distribution will be what is the chances of getting head?
1/2.
1/2. Okay. So we can say that it is 0.5. Okay, 50%. 50% of having head and 50% having tail, because only 2 chances. But now you have histogram for your height. Okay, histogram for your height. So the chances of having the distribution of the height, okay, generally, okay, it will follow normal distribution. This is uniform. This is uniform distribution. Uniform meaning you have a same chance. But in this case, this is normal distribution. Okay, normal distribution. We don't have equal chance for different height, but we have normal distribution. Okay, so there will be, most people will be in the middle. There will be a few people that is very short, very few people too high, very tall, but majority will be following this normal distribution. Okay, so the shape is not uniform, the shape is normal. We call it normal distribution. Okay, so let's say the height of majority of student, okay, can be let's say I just pick a number. Maybe let's say we can say 165, okay, millimeter. Maybe the extreme one is 180. Okay, we're going to have only one or two that's very high in your class, and there will be very few that is too short. Okay, maybe 140, for example. Okay, 140. So we're going to have here maybe 145, 155. Okay, here will be 175 and so on. Okay, so but most people will be in this region. Okay, so if the shape is like this, we call it normal distribution. Okay, so many phenomena in our life is follow normal distribution. If you have a grade, for example, student grade, grade for your course, okay, a normal grade will be you're going to have A plus, you're going to have A, you're going to have A minus, you're going to have B plus, and so on, so on. So those who have got A plus, not so many. Okay, maybe many people will be, maybe between, okay, maybe A minus or B plus, something like that. Okay, so if we plot this in terms of number, not many having A plus. Okay, A maybe slightly more, A minus is more. Okay, you have something there, and you have it here, and maybe one or two people will get C minus and D. Okay, so this also follow normal distribution. We call this a normal distribution. This is a performance in the course, for example. Okay, so in order to put what is A, you're going to have a what we call it a bin. Okay, we call it a bin or boundary of it. Okay, or we can call it a range. Okay, a range between 100 or A is what is A plus? I'm sure you remember what is A plus? Grade for A plus. Oops, sorry, dah hilang lah. Tak apa. Okay, what is the grade for A class? A plus. Okay, Iqbal, what is grade? What is the range for A plus? Hello?
Hello, Doctor.
Yeah.
Oh, yeah. 90 and above.
90 and above. Okay. 90 to 100, right? What is A?
80 to 90.
80 to 90. Betul kan ni?
80 to 90 kan?
Ni 90 dah ada A plus?
80 to 89, sorry.
89. What is A?
A minus. 75, right?
75 to
79.
79. Okay, what is B plus? $70 to $74? Okay, so now you have a range here, right? You have a range to classify. So if you put this histogram as this is A plus, this is A minus, sorry, this is A, it is A, and you have A minus there. You have B plus, here you have B. So that whoever score within this range will be counted in A lah. Whoever scored within this range will be counted as A. This is A plus, counted as A, and so on. Same thing also for your height, okay? For the height. and you are plotting the height of your class, okay, you have to know the range, okay, perhaps 170 to 180. Okay, it will fall under this category. Okay, and then for the next one, perhaps between 160 to 169, you will have to this one, and so on. Okay, so that you can finally get the shape of the distribution of the height. Okay, I would like to know, do you have any difficulty in preparing the histogram for the height, for the assignment? No response. I will call a name. Okay, Alvin, you have any difficulty in producing histogram? Alvin?
Hello?
Yeah?
No problem, but just the skewness there. When I
Oh,
want to
you
find
found,
like skewness and
you
kurtosis.
found the skewness, right?
Mm.
All right. How do you determine how many cells? Okay, we can call this also cells. Huh? The beans that I say just now, sometimes some people call it beans, sometimes they call it cells. How many cells? How many cells? Now we have 1, 2,
5.
3, 4, 5. How many cells in your case for the height? Can't remember.
Wait, I check back.
Right. Do you have it on your computer?
Yes, yes.
Okay, can you share with us?
Oh, okay.
Right. That will be easier for us to comment.
How to share?
You just go to, there is a button share there. Okay, good. Okay.
And this one. This is for the height.
All right.
And 5 cells for this one.
Okay, 5 cells. Okay, how you determine the cell that it will be 5?
Based on the data.
Yeah, okay. So based on
Then
data, you have data, I think it was what, 40 something, right? How many data you have?
43.
Okay, 43. Okay, 43 data is good number for you to produce histogram. Okay, so how many cells? The question now is how many? You have 5. Maybe your friend will have 6. Maybe some other student will have 7. Okay, there will other student maybe have 8. Okay, but if you have so many number of cells, okay, you may not have a good shape. Okay, if you have a large number of sample, you can have more number of cells. But for the case of data 43, having 5 cells is good enough. Okay, so what you did is correct. Okay, what you did is correct. So the only thing you say just now there is skewness, right?
Yeah, the skewness.
Okay, skewness happen here because the number of sample that we have is only 43. But if we take more sample, for example, the whole batch of third year student, you may have more closer to normal distribution. Okay, it will be closer to normal distribution when we have higher sample. But this sample is indicate that the sample is not big enough. It is sufficient to plot a histogram, but not big enough. Okay. All right. So you have another chart. It is on the left. This is what?
This is for the weight.
Aha.
But then this one I got 6 cells.
6 cell. Okay. 6 cell. Okay. Who determine the cell? You determine or you put it in the Excel? Excel decide.
I determine with because I do my own with this one, this the class here.
You do your own class lah. Okay. All right. If you change it to 5, maybe you get a different, slightly different shape lah. Okay. I think overall it's good that what you have shown. You have good understanding there. We see that now the weight. I think what you can explain here, because from the histogram we can explain the characteristic of distribution. How you describe this? the weight and the height. The height is more normally distributed compared to the weight, right?
Yes.
Okay, how you can explain the weight here?
Maybe you can say about the skewness of the graph.
Okay, they got the skewness, both have skewness.
This one is more to the normal distribution, and then this one is skewed to the left. Therefore,
Okay, you see that there are more people with this lighter weight, right? It seems that your class is ramai yang kurus lah ni. Is it correct?
yes.
Why? Because staying at home for too long, 2 years. So you eat less, is it correct?
Maybe.
Okay, so you see that you know many slim student on this graph. Hopefully that the estimate that you give correct lah. Okay, one possible error that we can get from this plot is because the weight was just estimated. Okay, I think many of you have not measured your actual weight. You just put the number. Okay, that could be
lesser.
Yeah, that could be one possible error. Okay, maybe the estimate was not accurate. Okay, because I just asked you to give the numbers, that's all. All right, but anyway, we can get many information from the distribution. My point here is, okay, when you put this, put it in graphical display, we can see the shape. Okay, we can see the statistical parameters. Okay, the mean, the skewness, the curtices, and so on. Okay, this basic information will be useful when we are discussing about quality. Okay, quality, as I say many times, is basically mainly based on normal distribution. Okay, based on normal distribution. All right. Thank you, Alvin, for sharing that. Okay, let me move on. Volunteer before I call. Okay, scatter plot. What is scatter plot? Do you want to see scatter plot between weight and height? Is there any relationship or not? Okay, Hazim, can you share your scatter plot? Student that is short and the height also the weight also low and the person is short. Okay, and there are very few. This is very tall in this case. You see my mouse or not? Okay, you don't see my mouse okay, tak apa. But anyway, you can see there is positive relationship. Okay, so one thing that we can say, there is positive relationship. Okay, so we don't have what we say is very strange lah if you can get a negative relationship, which is heavier person will have a short short interval of the height. Okay, but in general we can see that. Of course, there are not so clear in the case of this distribution. If you see that a lot of data are centering in the middle there. Okay, so when we're talking about this relationship, okay, Hazim, okay, you can unshare now.
Sir, Doktor.
Yes.
Paksi tu mesti start daripada kosong atau tak semestinya?
Not necessarily. Okay. So the axis, the beginning of the line not necessarily start from, okay. I think it's good question here because you're asking now should start from 0 or not, because zero height will be 0 weight, right? I think that is your confusion now. Is it correct? Okay. So in this case, we don't have to start in 0 because we are based on data. Okay. This is the data-driven modeling. So we just based on whatever data you don't have that data of 0 and 0. Okay, so we get the best fit. Okay, we get the best fit of this data. It doesn't have to start from 0 and 0. Is it okay?
Okay, sir.
Okay, no need to have to start from 0, because if we are starting from 0, is normally that graph normally we show, for example, forecasting data. Okay, but for data in terms of relationship between two variables, in this particular case, no need to have 0 and 0. So meaning that you're going to have, if you remember from your maybe mathematics, okay, let me put it here. Okay, so maybe the example here showing like this, but in the case of your data just now, okay, you may have a graph, okay, because everything is from the data that was given. So you may have a relationship something like this, for example. Okay, so this is like putting this y equal to mx plus c. Okay, so if this is y, okay, this is x, so they're going to have a cross. Of course, this is just estimate, okay, a model to estimate the relationship, So it doesn't have to start from 0. Okay, so of course we don't have a person which is 0 and 0 lah. Okay, we don't have a person which is 0 and 0. So there will a person that is the height is here and the punya weight might be here. Okay, it doesn't cross to 0. Okay, and also the visual can be misleading also based on the scaling that you use. Okay, the scaling that you use. So m will be the slope. Okay, so the c will be the crossing lah, crossing there. Okay, so where we use this in quality, okay, we call it quality tool, SPC tool. We use this to find a relationship. For example, process parameter. Okay, process parameter. I give you just now the process parameter could be speed and surface roughness. For example, in machining, okay, maybe you say the speed, okay, the cutting speed. And here maybe the roughness. You want to see, is there any relationship or not? Okay, the roughness of a surface that you are cutting. Okay, maybe we call it RA here, and the speed of the cutting, is there any relationship or not? So maybe you can say that the relationship is, after you plotting at different speed and you measure the roughness, maybe you're going to get a negative relationship, because higher speed might give you a more smooth surface. Okay, if you run at slow, you may get rough surface. Okay, what is the quality? Surface roughness is the quality. Is it clear? Yes or no?
Yes, betul.
Yes.
Okay, so we share this lesson. So now, another issue of putting the scatter plot, now we assume it is linear relationship. Okay, sometimes it is non-linear. Okay, this is linear, you have only straight line, but sometimes there is non-linear. Okay, we have to see whether it is straight line or is it going to be a curvature. Okay, the line might not be like this. The line might be, you might be getting a line maybe like this. Okay, so this is why we have to test it. Okay, what is the shape of the relationship? Okay, so for now we just assume that a simple relationship with a straight line, but you may have a relationship like this. Okay, in this case it is positive relationship. Okay, in this case there is there any relationship or not in this case?
Oh,
No relationship. So this is 0, almost 0. Okay, there is no relationship. Okay, no relationship. So we can say that regardless of the speed that we use, we're going to get a surface that is not necessarily better or not necessarily worse. No relationship. Okay, so that is the purpose of having scatter plot. Okay, let me go to this cause and effect, cause and effect diagram. So a lot of these tools are used in analyzing quality problems. Okay, used in analyzing quality problem. Okay, we have cause and effect diagram. Okay, cause and effect diagram. Okay, cause and effect diagram. So what we use here in the cause and effect diagram is we try to see what are the causes, okay, what are the effects. Okay, the shape looks like fishbone, and sometimes it's also called Ishikawa diagram. Okay, Ishikawa diagram. Okay, why? Because Ishikawa is Japanese. He introduced this diagram. Okay, so we have this showing the different category of cost. So normally we have major cost and we have minor cost. Okay, we have to classify it into major cost, and we're going to have minor cost. Okay, major cost, minor. For example, you may have the problem of people. Okay, what is the effect? Maybe high defects, okay, high rejection rate because of people. Okay, because of people or because of workers. And you may also have category, maybe a machine. Okay, these are major costs, major category. Okay, you may have also a category of machine, people, maybe material. Okay, material, another category. Okay, maybe another is system or environment. Okay, so under this you're going to have sub area. Okay, what are causing the people? Maybe the training is not enough, maybe the attitude is a problem, maybe the health condition of the people is no good. The effect is what? High reject, high mistake happening in production. Machine, maybe the problem of machine is frequent breakdown, maybe the machine is old. Okay, so all these we put it as one category in the branch of fishbone diagram or Ishikawa diagram. Okay, we have material, we have system. Okay, there are subcategory of those. Okay, so this is number two. Number one. Okay, I did not follow the sequence because I go to what is more easier to understand. Okay, in the flow chart. Okay, normally we use flow chart. Okay, this is to summarize descriptive procedure into flow chart. Okay, we can use symbol. For example, flow chart we using the circle. Okay, maybe this is step number one. Okay, step number two. Okay, for example, when you go to registration office to renew your what do you call it, your IC, your IC, or you want to go and to produce to request for your passport. Okay, you have to follow certain step. What is a step one, step two, step three? Okay, instead of we explain verbally in terms of descriptive paragraph, it's easier to put in flowchart. Okay, so you can see this flowchart is widely used in offices, in government department to describe the procedures. Okay, the procedure is explained in flowchart. Okay, so how do we use this flowchart? We can analyze the flowchart. Okay, whether it is a good flowchart or it is inefficient flowchart. Okay, so from the flowchart we can have it existing method. Okay, or we can say a present method, or okay, we can have present method and improved method. Okay, we make comparison. Flowchart for the present method. Currently, how it is being done. And then we can have improved method. Okay, we put it in flowchart. So we identify, okay, what are the steps which are not efficient. Okay, what are the steps which are not efficient in the activities. Okay, so okay, what are the normally symbol that we use in industrial engineering? We use circle. This is operations. Okay, different symbol is used in different area. If you go to computer science, they use a different symbol for flowchart. Okay, in IE, industrial engineering, we use, this is for operation, which is a circle. This is square is inspection. Okay, we use this as inspection. Okay, you can have this triangle as a storage. Okay, we represent the activity by using different symbol for the flowchart. Okay, you can have this arrow like this. This is, we put it as transportation. Okay, if we are moving something, okay, we put an arrow like this in the chart. Okay, transportation. So it's more detailed than general flowchart. Transportation. Okay, so we can have, okay, we have square. We also have this, what we call it like D. Okay, the shape like looks like D. This is we use for delay. Okay, delay. When something is delay, waiting, we put a D. Okay, so from there we analyze whether the process is efficient or not. If it's too much delay or too much movement, meaning that the process is no good. Okay, so you may have, for example, the activity coming from, okay, let's say it is moving. After the moving, is go to delay. Like you go to petrol station, you move to the petrol station to fill in your petrol, and then you delay, which is you are waiting the queue. Okay, and then you start to, you know, open the pump. Okay, and now you are okay, while waiting, the pump is being done. Okay, there is another delay there. Okay, after that, maybe you do the inspection to see that the tank is full or not. Okay, and then finally, maybe you can say, okay, I want to park my car. Okay, you put the car into storage. So we can see that there is a flow there. Okay, from here, the flow chart tell us easier compared to we explain descriptively about this activity. All right, so I have explained the flow chart, cause and effect. Okay, let me move a bit more on. We have other it's not moving. Okay. Okay. So I think the time also up now. We have roughly finished this. Okay. Any question so far? Is there any question? Yes or no? Okay, if you don't want to speak. Okay.
No,
All right. Okay, I owe you that 2 hours class. So it seems that many of you are still unable to agree with the common time. I will let you know later on. Okay. For the time for replacement. But for this, what we learned today, okay, I would like everyone to find example. Okay, you can Google an internet, or you can have your own example of fishbone diagram and example of flow chart. Okay, so you can find example of those. And next class, okay, I would like you to share with the class what example that you got. Okay, it could be a flow chart for registration process. It could be a flow chart for manufacturing process. Okay, and also fishbone. Okay, take example for fishbone. It could be example of fishbone for identifying the causes of a problem. For example, fishbone showing the causes for high accident rate. Okay, what are the causes that high accident rate happening in Malaysia? Road accident, for example. Okay, you find what are the causes. So you can come up with your own, or you can just go and Google it somewhere. And next class, I will randomly ask you to share. Is it okay? All right.
Okay.
All right. If there is no question, we stop here. Thank you very much.
Doktor, ada attendance tak?
Attendance.
Okay, I will put attendance after this in the Telegram and you scan from there. All right. Okay, thank you. Okay.
Thank you.
Okay, sama. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
Assalamualaikum.
Terima kasih, Doktor.
Sama.